Welcome back again in my channel Physics 21. In this video, I am going to prove Newton's second law of motion will be the real law of motion, because we can prove Newton's first law of motion as well as Newton's third law of motion using Newton's second law of motion. So in first step, I will prove Newton's first law of motion with the help of Newton's second law of motion. So as we know that from Newton's second law of motion, force F is equals to ma. Let this is equation 1. Using equation of motion, we can write V is equals to U plus AT. As we solve it, we get A is equals to V minus U divided by T. Let this is equation 2. Now from 1 and 2, we can write F is equals to M in bracket V minus U divided by T. If there is no force, means if F is equals to 0, then we write M in bracket V minus U divided by T is equals to 0. Here, M not equal to 0 as well as T not equal to 0. That means V minus U is equals to 0 or V is equals to U, which is Newton's first law of motion. If V is equals to U, then there is no change in the velocity of the body. For example, if initially the body was in rest, then it will be in rest if there is no force. So which is inertia of rest. If the body is in uniform motion moving with some velocity u, then it will continue same uniform velocity. This is the inertia of motion. So overall we can say this is Newton's first law of motion. That means we are able to prove Newton's first law of motion with the help of Newton's second law of motion. In next step, we will prove Newton's third law of motion with the help of Newton's second law of motion. Now the proof of the Newton's third law of motion using Newton's second law of motion. So let there are two bodies of masses m1 and m2 initially moving with velocities u1 and u2 respectively. After some time, these bodies will interact with each other and separate it. So after the interaction, let their velocities are v1 and v2 respectively. During the interaction, both the bodies will apply force on each other. Let force on first body is F1. It will be equal to the rate of change of linear momentum of the first body. So here, the rate of change of linear momentum of first body written as m1 v1 minus m1 u1 divided by t. So this quantity will be equal to F1. Now this is equation 1. Now F2, which is the force on second body, it will be equal to change in linear momentum of second body. So we will write m2 v2 minus m2 u2 divided by t. Equation 2. Now as we add equation 1 With equation 2, we get F1 plus F2 is equals to M1 V1 minus M1 U1 plus M2 V2 minus M2 U2 whole divided by 3. Now as we rearrange the terms, we get F1 plus F2 is equals to M1 V1 plus M2 V2 in first bracket minus M1 U1 plus M2 U2 in second bracket whole divided by T. That this is equation 3. Here M1 V1 plus M2 V2 will be the total final linear momentum of the system denoted by Pf. That this is equation 4. And M1 U1 plus M2 U2 will be the total initial linear momentum of the system denoted by Pi. Let this is equation 5. From the conservation of linear momentum, as we know that in the absence of the external force, the total linear momentum of the system will be constant. So we can write Pf is equals to Pi by the conservation of linear momentum. That means in equation 3, this term M1 V1 plus M2 V2 minus in bracket M1 U1 plus M2 U2 will be equal to 0. So we can write from equation 3 F1 plus F2 is equals to 0. That means F1 equal to minus F2. This is Newton's third law of motion. According to Newton's third law of motion, for every action, there is equal and opposite reaction. So we can say this is the proof of Newton's third law of motion. So it is clear. Using Newton's second law of motion, we can prove Newton's first law of motion as well as Newton's third law of motion. So the Newton's second law of motion is also known as the real law of motion.